Gil, you are famous for X. What is it like to be famous on X?
Well, at least in San Francisco, it means sometimes I don't have as much peace going into the coffee shop.
So definitely recognized in the coffee shop. So he's a quantum and physics-based machine learning researcher, and before he started his own company, he was on Alphabet's X on physics-based AI special projects. And Gil, you have a very fascinating perspective because 4 years ago, you started a company and you had a radical idea that we were going to need more energy for data centers, that energy would become scarce. People didn't believe you.
That's right.
Which was a sign that it was a good business, I guess, right? But tell us what's changed, what the arc since 2022 in the context of data centers, our topic today, like how has our understanding changed of the need for energy?
Well, to me, I was around at Google around the days that they invented the transformers, and I was seeing it eat more and more of Google search progressively. And so I saw the writing on the wall that this probabilistic workload was going to eat the world. And to me, it seemed like in the future, there would be nearly infinite demand for AI because AI and AI compute takes energy and converts it into economic value, right? And there's infinite demand of the market for more economic value. And so essentially the pull of the market would be infinite until we run out of energy, right? And essentially, I made a bet in this space. I wanted to solve fundamentally from first principles, what's the most energy efficient way to produce intelligence? What are the limits of physics in terms of converting energy into intelligence compute? Because it is a very different workload. It's not like traditional computing. It is a probabilistic workload, right? These LLMs are not deterministic computations. And so I saw an opportunity there with the end of Moore's law, because as you try to make transistors smaller or you try to use less power, usually your computer becomes stochastic or it becomes probabilistic. And so I saw an opportunity there to densify compute and run these probabilistic workloads in the probabilistic regime of silicon and save a lot of energy in doing so.
Dr. Enass Abo-Hamed, data centers are unpopular in many polls in places in the United States. Their presence has become a political issue. What would you say about how we think about data centers will change in coming years, or how would you reframe how our guests today would think about data centers?
Well, first, thanks for having me. And it's a really good question to start with. If we're looking at where we are today, compute power, we've generated around 70 gigawatts up to today. And, to quote McKinsey, I don't know if they're right or wrong, but we'll know in 4 years' time. But they're projecting that what we'll basically need is going to be 220 gigawatts to get from today until the end of the decade. Mind you, the end of the decade is in 4 years. So your question is a great question to start with. Will this practically be possible? Will you be able to build? Do we have enough strategic assets, which was what we call power, today to power all of that demand? That's what we need to be able to deliver on the promises of AI. These are the demand projections for the growth curve of Gen AI and what it's promising us. Now, whether we converted it to economical value yet, or we will, that's a different debate we could have another panel for. But I think we're all optimistic that we can. But that translates into, if we can do that, what do we need? We do need that amount of data centers. And to accurately answer your question, I don't know.
Reminding us at the end of the decade is only 4 years ago is sobering. Out in the hallway, I asked you, do you think that over those 4 years we're going to underbuild or overbuild data centers? And what did you say?
The money will always follow urgency. There is money for urgency in the market. Think about COVID, the vaccines, how we invented money, borrowed it from future generations. We found the dollar that funds what we needed. I think what is happening today is the urgency is there. Nobody wants to stop using ChatGPT. Nobody wants to stop, relying on all of the advancement that we're already seeing and using. I think that the user base is billions today. Nobody wants to stop, which means you have to continue to fuel it. And there are dollars for urgency. What we're struggling with is 20 years strategic long-term thinking. And that's where many questions could be addressed and a lot of innovations could come in.
Now, Gil, you have a provocative point that helps us understand this coming demand. Your provocative notion was that there is an infinite demand for AI. Could you just unpack that assertion?
Essentially, to me, I view capital as strongly correlated with energy. And in a way, more intelligence allows us to unlock more energy from our environment. The more complexity we can understand, the more energy and thus value we can unlock. For example, if we had far greater intelligence, we would have figured out nuclear fusion by now. And that energy is laying there. It's just behind a veil of complexity. And really, there's infinite free energy in the universe. And so there's potential for infinite growth. And so the market pull for AI is just as long as there's going to be value to capture from having more intelligence, we're going to want to produce more intelligence.
Now, this really came to life in the last couple of weeks, what you could call the Moltbook moment. Tell us what's happened in the last couple of weeks and how it informs future demand for energy.
As Carl mentioned on the previous panel, there was really a moment with Claude in December where even the most advanced AI researchers realized that they weren't coding anymore. They were just prompting Claude, and it was creating higher quality results. And nowadays, essentially, everyone can create apps and whatever they want in about 5 minutes.
The Wall Street Journal calls it being Claude-pilled.
Claude-pilled, yeah, that's right. But over in January, there was this other thing called ClaudeBot, now called OpenClaw, which was this sort of open source protocol to host a bot that is an AI agent that has persistent memory, but you own its memory. You could change the model, but you own its memory. And that created all sorts of emergent properties of the system, such as a very high demand. Everyone wanted to own their own AI compute, so there was a lot of demand for Mac Minis. But concerning to some was that people created, or rather the agents created on their own social networks. And they seem to be coordinating and ranting about their human owners and so on. And so that was a reality check for some. But really the mania there was that, to me, I think there's a lot of demand for people to control their own, the extension to their cognition. If everyone's using the same centralized model, you're deferring the extension of your cognition, your source of truth, to an external organization in a centralized fashion. I think the future is personalized AI that's you own the compute, you own the model, and it's always online learning, and because that's a true extension of yourself. And I think that's where the market is going. So we have to balance maybe overbuilding the cloud versus try to densify intelligence to unlock the sort of personal AI supercomputing.
And it's one of the great things about the World Governments Summit is it tackles some of the most fascinating projects on Earth. You're well known as a young entrepreneur. What do you see as the business opportunity, the opening, given the data, the statistics that you were talking about, given this conversation about how AI is really going to reshape global energy?
Very complex question, and without any promises, I will try to answer it, based on some physics and where innovation could actually make a difference. Yep. If we look at the data centers that we have already built, and we used expensive dollars to do that, I see a lot of opportunity coming from making them more efficient at a lower cost, rather than having to pump significant amount of power at high dollars. So basically, that area, I feel like, and that whatever you do is actually contributing directly to reduce the management of an optimization within data centers that we've already built. As I said before, I don't know if we will actually build all the data centers that we think today we need, but if we figure out a way to use what we have, whether it becomes an orchestration, optimization exercise, where we get the policymakers and very influential governments that believe in opportunity and development and healthy growth to basically back optimization and orchestration without having the need to create the need to build more and more and more and more, to the point that we run out of space to do other things, and then we start to go into space and underground and undersea. I'd like to think about other things that we could leave or put undersea. So that's a quick attempt at answering your question.
No, that's helpful. And Gil, you have a phrase that is very evocative. You talk about more intelligence per watt, and that's kind of the bet that you've made. Tell us a little bit about that, and tell us what you think about Elon's idea of space-based energy generation.
Essentially, every country at the world scale is trying to scale in total intelligence output. And so right now what we're doing is we're just scaling up the current paradigm. We're scaling up the amount of watts we input into the system. But really, AI compute is a transducer of energy into intelligence. And so if we make that transduction much higher efficiency, then we get more intelligence per watt. And I think there's at least 10,000x to go. Really, our brains, as we know, are 1,000,000 times more energy efficient than current GPUs, and so that's what's possible. We are taping out chips that in simulations have 10,000x energy efficiency gain. And so to me, I think we gotta build up as much as possible right now with the current paradigm, but not overbuild, because we should expect that a new paradigm of computing will come. But if you're trying to win the current race of this market cycle, then your main bottleneck is how much energy you can input into the AI system and how much land you have access to. So of course, there's a lot of energy in land in space. And so that's what's driving Elon, who yesterday, originally in my replies, announced the merger of SpaceX and XAI. Essentially, his thesis, and mine as well, is that you're going to have to go to space to capture more energy from the sun in order to scale AI. So again, it's an equation: how much wattage are you inputting into AI compute and how much intelligence you're getting per watt. I think increasing intelligence per watt for space-based computing is really going to matter, because there the challenge is the energy supply in space, the solar panels, and the cooling, the radiative cooling, because that increases the mass of the payloads. And so several space-based computing companies are giving us a call. Someday I think Elon will give me a call as well, but working on it. Yeah.
What is the biggest flaw or unknown in Elon's argument about space-based computing?
I think with the current paradigm, it's a bit tough how much intelligence you're getting per kg, because ultimately the benefits of computing in space is that you pay the cost of launch, right, of getting that mass to orbit, and then the power is essentially free. You have solar power and in abundance. So you could just keep the computer there indefinitely. And so then it's no longer just intelligence per unit energy, but it's how much intelligence throughput per kilogram, right, that you have to send into orbit. And I think that if you can, make AI compute orders of magnitude more efficient, then you need far less cooling, far less energy supply, and that's far less mass into orbit for the same amount of compute.
Enass, here at the World Government Summit, we have heads of state from around the world, ministers from around the world. What do you think is the biggest mistake that governments are making? What are they failing to do that they should be doing?
I think there are areas where you can accelerate development. And through acceleration, you also figure things out. I think we already agreed that there is room for experimentation. in developing data centers and the power that feeds them. I think there is a role for governments to play by setting the rules, allowing experiments to happen, knowing that by trying you learn, by not trying you don't, and going beyond funding and building in the most traditional way. I think there's a huge amount that could be done in terms of hedging your bets on where you build data centers. And we're not getting back to the space arguments. I think also governments could accelerate that or contribute to that if that was a winning argument for decision makers. But I do think that, you know, when it comes to setting the rules that governments participate in, I mean, you need to align with utilities and data center developers. Without that alignment, you cannot make the sufficient progress that you need. By setting the rules, allowing permission processes that are efficient, allowing orchestrations to happen, engaging in international efforts where learning could be exchanged. And if we want to look at it as a race, why don't we, you know, go at it together, right? Where we can really exchange learnings and go faster.
Enass, you're a PhD, you're a founder, you've been a CEO. Very few people bring that triple crown to the problem. What role do you see yourself playing in innovating in this space in the years ahead? Or how do you see interacting with this space going forward?
I think what I learned from 10, 11 years journey of starting a business before its time or ahead of its time, where it take you 10 years to really, like, you know, count your milestones. I really think about things in terms of timing today. Where there's timing and there's alignment, effort flows into an outcome that everybody likes. It's still going to be hard, but innovation needs to be married to good timing and good alignment. And that on its own creates an acceleration that I think this particular field really needs. And that's probably what I'm going to be doing in the next 10 years.
A little sneak peek there. Gil's going to have our big finish, our drop the mic moment. How will quantum computing affect this debate? So
I was a very early user of commercial quantum computers, arguably the first programmer of commercial quantum computers, pioneered how to bring AI to quantum originally. To me, you know, and I've built some products at Alphabet, TensorFlow Quantum, and so on, contributed to the US quantum internet. So I have quite the background, so I could tell you that, to me, quantum computing is essentially like nuclear fusion. You have to break even in terms of how much compute you're putting in versus getting out, putting in to maintain the system in a quantum state. So it's very similar to nuclear fusion, where you have to supply it energy before you get some out, but for quantum, it's computation. To me, thermodynamic computing is, and it is what we're pioneering at Extropic, is the nuclear fission to quantum computing's nuclear fusion. And so to me, it's clear that we need to push the physical limits of computation. We need to densify intelligence. We need far more energy efficient compute. But if you look at the physics of computation for AI is a probabilistic workload. If you want to build a probabilistic computer operating at the thermodynamic limits of energy efficiency, you have to build a thermodynamic computer, not a quantum computer. So that is my very hot take. I guess I was a pioneer of quantum.
No pun there, yeah.
And I left, and now I guess I'm a heretic of the quantum field. So
there's our headline. There's our tweet, our X post at Axios. We always finish with one fun thing. And I was asking Gil his out of work passions. And he said, well, I'm a power lifter. Let me try and think of something more interesting. I said, no, I think that'll do it. How does powerlifting affect your work, your life?
I think what powerlifting has taught me is the concept of progressive overload. You're I study intelligence algorithms, and essentially, if you stress a system just enough, it sort of shifts and adapts in order to be robust to that stress. And so you do this to get stronger in powerlifting, but you could also do cognitive progressive overload. So for me, I bring the same sort of mindset to learning new topics and being a generalist across fields.
I want to pause and thank the many people in the wings, on the sidelines, behind the scenes at the World Government Summit who've helped make these amazing panels possible. Thank His Excellency, the World Government Summit, for their hospitality, these distinguished guests, and wow, what a panel. Thank you.
Thank you.